Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 7, Section 5, Slope. Now, we've talked about slope and rate of change and all that in previous videos a little bit, and so a lot of this is going to be review, in a way, but we are hopefully going to add a couple of new elements to this. Now, slope describes the steepness of a line. It is the ratio of the rise, or in other words, the vertical change, the up and down change, to the run or the horizontal change. So when you have a line, two things are happening to this line. It's moving to the right in this case, and it's moving up. So it's changing in two directions. It's changing vertically, which is up and down, and it's changing horizontally, which is left and right. This line is moving forward and up, forward and up, forward and up. So it's changing in two directions. Those directions are the rise and the run, as they call it, because when you ride, the reason why they call it rise over run is it's a nice little way to remember slope. Slope is the rise over the run, the change in the up and down movement over the change in the left and right movement. When things rise up and down, they're moving up and down. When you run, you're running left and right. Okay? If you were to be running on this board, if you think of it like a video game, I guess you could say a 2D video game, you run left and right, you rise up and down. So that's kind of what slope represents, and that's what the fraction. Slope is always, you always want to represent slope in a fraction. If slope is not in a fraction form, if you see a 2, for example, as the slope, then you always need to take that 2 and put it in fraction form. If you have just a regular number by itself, to write it as a fraction, it's always over 1. So you have up to right 1. Now, something to take note of when we're talking about rise and run, or vertical change over horizontal change, is what do the numbers mean? Positive numbers, depending on whether or not you're looking at the rise or the run, are up or right. So if the rise is positive, it's up. If the run is positive, it's right. Okay? A negative number means that it's moving down or left. So if you have a negative number in the rise, it's moving down. If you have a negative number in the run, it's moving left. So again, make sure you're pausing this if you need to. Take some good notes. Absorb this. If you have questions, pause the video, let me know. All that good stuff. Okay? We've also talked in previous videos about the formula to find slope that uses 2 points from the line. So if you have 2 points from the line, you can use that formula, the slope formula, y1 minus y2 over x1 minus x2. And remember, these little numbers down here are just labels. They're letting you know that y and x come from the same ordered pair. Y and x that have 2 on them, they come from the same ordered pair. They're not exponents. They don't mean anything. They're just labels, letting you know that these are a pair and these are a pair. Okay? So that's, again, a little bit more review from some previous videos, but nothing, review is not a bad thing. Okay? So there's a couple different ways you can find slope. If you can, well, basically, this y1 minus y2 over x1 minus x2 formula, what it's doing is it's finding the rise over the run for you. It's finding the vertical change for you, and it's finding the horizontal change. So how does it do that? How does that formula work? Basically, what's going on here, I'm going to move this out of the middle of the board. I'm going to put it up here where we can look at it, but it won't get in my way. Okay. Basically, what's going on here is you've got 2 points on your line. Each point has an x-coordinate and a y-coordinate. So if I have a line, okay, and I have a point here and a point here. Let's say this point was at the ordered pair of 4, 7, and this one was at the ordered pair of 2, 4. Okay. Now, remember, in ordered pairs, the first number is always the x-coordinate, the second number is always the y-coordinate. Okay? So, what this ordered pair is telling us about these points is it's telling us, the x-coordinate is telling us, on this coordinate plane, so let's draw the coordinate plane real quick. Okay? On this coordinate plane, it's telling you how far left or right on the coordinate plane your point is. My coordinate plane is 2 spaces to the right from the origin on my x-coordinate plane, on my coordinate plane. So here's the origin, and this 2 is telling me that this point here is 2 spaces over to the right. This coordinate here, the y-coordinate, is telling me that my point is 4 spaces above the origin. So we're 2 spaces to the right and 4 spaces above. Now obviously this is not drawn to scale. This isn't 100% accurate where I place my dots. I'm hand drawing it, making it up. So you're just going to have to pretend for a moment that this is actually 4 spaces up and 2 spaces over. This point over here is telling me that I am 4 spaces over from the origin and 7 spaces up. Now, subtraction. The reason why we're subtracting the coordinates here, subtraction tells you what is between 2 things. Okay? Whenever you subtract, if I do 10 minus 7, the answer is 3. So when I do 10 minus 7 and I get 3, that's telling me that there are 3 spaces between 10 and 7. So there are 3 spaces between 10 and 7. If I do 5 minus 1, then that's going to tell me that 5 minus 1 is 4. And so the answer is telling me there are 4 spaces between 5 and 1. So subtraction finds you what's between 2 things. If I can successfully subtract these 2 points, I can find what's between them. So when I subtract my y-coordinates, okay, when I subtract my 7 and my 4, okay, so we're going to have a 7 here and a 4 here. When I subtract those, I'm going to get an answer of 3. Now what that's telling me, since I subtracted my y-coordinates and I got an answer of 3, that's telling me the vertical distance between my 2 points is positive 3. Okay? Now my y-coordinates represent how far above the origin my points are. They represent the vertical distance from the origin. So if this one is 7 spaces up and this one is only 4 spaces up, then that means between them, moving from the bottom point to the top point, this represents 3. There's my rise, to go from one point to the next. That's what this is telling me, to go from point 1 to point 2. I have to rise 3, and now I need to figure out how far do I have to run. So we're going to take our x-coordinates, and we're going to subtract them. So if I did 7 minus 4, I'm going to do 4 minus 2 for my x-coordinates. X of 4, x of 2. Because remember, the 4 and the 2, the 4 and the 2, they're from the same ordered pair. The 7 and the 4, 7 and the 4, they're from the same ordered pair. So now I'm going to subtract my x-coordinates. My x-coordinates tell me how far along on the horizontal x-axis I am. So how far to the right or left am I? Well, when I subtract them, it's going to tell me how much horizontal distance is between my 2 points. So when I do 4 minus 2, I get 2. So that's telling me there are 2 spaces horizontally between my 2 points, which now means my slope is 3 over 2. And remember, this is my constant rate of change as well. This is the ratio of the rate of change for my points. And you pick any 2 points on a line and you find the vertical and horizontal distance between them. The answer will always be a ratio that's equivalent to 3 over 2. Okay, so you may not necessarily get 3 over 2 exactly. You might get 6 over 4. You might get 9 over 6, something like that. But you will get a ratio that is equivalent to 3 over 2. So what this is telling me is that anytime I go up 3 over 2, up 3 over 2, up 3 over 2, every time I do that, I'm hitting another point on my line. I'm traveling at the same rate, is basically what it's saying. So this could be saying that I am going 3 miles in 2 hours. So after 2 hours have passed, I've gone 3 miles. After the next 2 hours have passed, I've gone another 3 miles. Another 2 hours has passed, I've gone another 3 miles, because I'm going at a constant rate of change, or a constant speed in this instance when I'm talking about cars. So if I'm going at 3 miles every 2 hours, then my speed is constant. So I went 3 miles, 2 hours passed. 3 miles, 2 hours passed. 3 miles, 2 hours passed. That speed is constant. It's not changing. So my line is straight. And I'm always, every time I go 3 miles in 2 hours, I'm at another point in my line. Okay? So that's one way of finding slope. And that's going to be your primary method for finding the slope. Because this formula works in all instances. Okay? This will always be able to find, as long as you can figure out 2 points on your line, this will always work. Now, we will discuss what the equations, linear equations, will look like, and how you can come up with and how you can find 2 points on your line. As long as you have the linear equation, you will always be able to find 2 points for your line. Now, there is a second method to finding slope. It's not as useful. It only works when your numbers are very small, okay, that you're working with. When your lines, when the pieces of the line that you have represent small numbers, and it works especially well when your numbers are not fractions or decimals. When you have whole numbers, the numbers are small and simple. So for example, if you're looking at a graph, and they've given you the line, and you've got 2 points. Let's say we've got a point right here, and we've got a point right here. Okay, and obviously it's easy to count. Okay, I'm going up 1, 2 over 1. So at that point, what I've done is I've counted my vertical distance, my rise, and I've counted my run. I went up 2 over 1, so my slope is 2 over 1. So you can actually use the graph to tell. However, a couple problems arise. Sometimes when you're looking at these graphs, you're moving up, 5.63, and it's going to be very hard to see that if I'm moving up a fraction of a number. So it's going to be very hard to see that I'm moving up 5.63. The other thing about the graphs is sometimes these graphs are all the way up in the millions, depending on what kind of charts you're looking at. I mean, if you're looking at business data, then a lot of times you're looking at numbers in the thousands, hundreds of thousands, in the millions, and so counting from one point to the next when there are millions of points between them is not too feasible. It's going to take a while. I mean, even if there's just 100 points between them, you don't want to sit there and count 100 points. And finally, the last thing that can catch you up when you're trying to find slope using the actual graph itself is the fact that the horizontal scale doesn't necessarily have to match the vertical scale. And what I mean by that is I may be moving and counting each slash here as 1 for the horizontal scale, but I am more than welcome to move up by tens over here on the vertical scale. The two scales don't have to look the same, and so you have to pay attention to those numbers to really understand, is this really going up 2, or am I going up 20 in this case? So in this case, I'd be going up 20 over 1. So that's another thing that you need to keep an eye out for when you take a look at these things, because that can drastically change the problem. So that's really all I'm gonna put out there for this video. This is simply a video on basically how to find slope and what slope is. In the next video, we're gonna go over 2 special types of slope. They're called zero slopes and undefined slopes. So tune in.